This video will cover data structures in Python. If you go to the class schedule, you can click on the slides for data structures, which I have loaded up in this other tab. And it's important to go through these slides on your own. It's important to go through the book on your own because the purpose of these videos is not to cover every detail, but to really cover the concepts to help you understand how all these different concepts in Python work. All right, and so for this video, I'm going to focus on lists, tuples, and dictionaries. Those are really your core data structures in Python. You can read about sets on your own. I've often found them useful many times, but I'll leave that for you to study. Okay, so as before, we will go to my terminal. I'm in the operating system shell now because I see the $sign there, and I will invoke the Python interpreter with Python. Okay, so we've covered atomic values so far. So for example, I could say ned is a variable which references a string value. And if I say ned, value of ned is ned. And I can say cat gets the value cat. And now cat references cat. But what if I wanted to group multiple things together? Well, one of the ways to do that is to use a list. I can say Starks gets the value, and I'm going to enclose values in square brackets. Starks gets the value Ned, Cat, Rob, Sansa, Arya, and let's put John in there. Okay. Now, Starks references a value which is a kind of collection that we call a list. Lists are represented in string form as elements, values separated by commas and enclosed in square brackets. All right, so we call this a list value, this whole thing a list value, and we call each of these values in the list that are aggregated in the list as elements of the list. Okay. All right, so let's draw this out to sort of understand the concepts. Okay. So what we just did is we created a variable called Starks, and it references a list. And I'm drawing this out. There are lots of ways you can draw this out conceptually. Some people do linked lists and so on, but I think this works pretty well. So we have these elements of the list. Rob, Sansa, Arya, and John. Okay. Okay, so a list is a sequence. So a list is a collection whose elements have an order. All right, and the order is determined by these indexes. So there is a first element, which is at index 0, a second element, which is at index 1, third element, which is at index 2, and so on. And again, because we start our indexes at 0, then the last index is the length of the list minus 1. Okay? So it's like each one of these boxes right here is its own variable. Let me show you what I mean by that. So if I say Starks 0, sub-0, pronounce that Starks sub-0, that gives me the first element of the list. As with strings, it's a sequence, so I can take the length of Starks and it tells me 6, which means that Starks sub 5 gives me the last element of the list. All right? And it's like each one of these variables, Starks sub 0, or these index references, Starks sub 5, and so on, it's like they're their own variables. You could think of them that way. All right? Now, I'm using the term subscriptable because a list is a sequence, and I can get at the elements of that sequence with a subscript operation, which is to put, for a list, an integer in square brackets. Now, if I have another kind of variable, like x is 1, it doesn't really matter what it is, and I try to access x sub 0, then I get the error that an int object is not subscriptable. That means int is not an object that has elements that can be accessed with an indexing operation. Okay, so that's lists. All right, so lists are mutable, which means that I could do something like this. I could say, let's talk about indexing first. Okay, when I say Starks 5, that actually gives me a copy of that value that's at position Starks sub 5. Here's what I mean by that. Let's say I make a variable Azor Ahai gets Starks sub 5. All right. So now Azor Ahai is John. Starks sub 5 is John. Now, if I say Azor Ahai gets Harris, I think I've spelled that right. Now, Azor Ahai has that value, but Starks sub 5 is still John. Because back here, when I referenced Starks sub 5, that gave me a new value. All right, so anytime you do an indexing operation, and that includes slices, that creates a new value. It doesn't modify the original list. So this is not, as in some languages, so some languages work this way. Some languages would then make Azor Ahai actually a reference for the fifth element of the list, rather than assign to Azor Ahai a copy of the value at Starks sub 5. And in Python, what's happening is that we're making a copy of the value at Starks sub 5 and assigning it to Azor Ahai, which is why initially Azor Ahai had the value John. All right. Okay, so I said that lists are mutable. That means that I can reassign the elements of a list, but I have to do that using using the subscript on the left-hand side like this. So I have to say, for example, Starks sub 1 gets Lady Stoneheart. I know I'm kind of messing all this up, but now Starks is Ned, Lady Stoneheart, Rob, Sansa, Arya, and John. All right. Now, if I wanted to extend this list, let's put some of the wolves in there. There's a couple of ways I can do this. You can use list operations, list methods, or you can use indexing and slicing. So if I say Starks plus, so first of all, it's important to remember that if I want to add something to the list, I don't use plus. If I say Starks plus, let's say, Lady, you can only concatenate a list in a list. So if I wanted to add Lady, I would have to put Lady in a list. All right? But notice that this actually creates another list. So Starks doesn't contain Lady. If I wanted to add Lady to the list, I would say Starks.append lady. All right. Now Starks has lady. And if I wanted to add multiple values, I would use extend. And I would extend it with another list. So lady, ghost, and what does she call him? Nymeria? I'm probably butchering the spelling. Okay. And now Starks has, I know there are more wolves than that, but I can't remember their names. All right. Okay. Now, you can put anything in a list. So a list is a heterogeneous data structure. All the data structures in Python are heterogeneous. What that means is that, so I have, let's make another list. So I could have a list with 1, 2, 3, right? And let's assign that to, say, vowels. Watch what I'm going to do here. Now, I just evaluated something in the REPL, right? And I forgot to assign it to a variable to make things easy on myself. So the last thing that you evaluate in the REPL is assigned to the special variable underscore. So if I ask Python to give me the value of the underscore, then it gives me that last thing I typed in. So if I want to save that, vowels gets underscore. Now vowels is referencing that list. Okay. All right. So, but notice that the type of vowels sub 0, oops. So I got the continuation line there because I forgot to type the closing parentheses. So the type of vowel sub 0 is int. The type of vowel sub 1 is string. So you can have mixed values, values of mixed types in a list. You can even do something like this. Starks sub 5 gets John Jaharis. And now Starks, which has become quite long, has an element that is itself another list. So if we look at that conceptually, the way that looks is now, let's see, so now Starks sub 5, eraser's kind of awkward. Now itself points to a list, I'm sorry, references a list, which references John and Jaharis. Okay. All right. Now notice notice that you could consider this a tree structure. You can actually represent tree structures by nested lists, and this is a common thing to do in many programming languages. So it's very easy to represent things like lists or things like trees in Python as lists with nested lists. You don't have to create these special node data structures and so on, you know, classes and stuff like that. You can if you want, but you don't have to. Okay. So that's lists. What are tuples? Tuples are like lists, but they're immutable. So tups gets Stan, Kyle, Cartman. Okay. Now tups has those elements. I can index them just like I would any other sequence, but I can't reassign them. Yeah, because tuple object does not support item assignment. You also can't extend them, so there's no append operation. So I'm hitting tab here, and I'm not getting any tab completion. And if I wanted to see, for example, what kinds of operations are available on tupes, I could say help tupes. And now I'm entering the Python help system, looking at the class tuple. All types in Python are represented by classes. And I'll scroll past these dunder methods here. These are methods that start and end with an underscore. And we'll learn about those later. And we see that there aren't many things available, except for get attribute, which is actually sort of a special function that implements for us indexing. So that gives us tup sub 0, for example, tup sub 1, and so on. Now, the cool thing about tuples is that you can create them with commas. So if I say 1, 2, that creates a tuple. And I can do tuple assignment, and I can say x, y gets 1, 2. Now, what that does is, on the right-hand side, this is an expression that creates a value, and the value is a tuple whose first element is 1 and second element is 2. And what this does on the left-hand side, this is called tuple unpacking assignment. And what it does is, as long as the number of values on the right-hand side matches the number of variables on the left-hand side, it assigns them by position as you would expect, so that now x has the value 1, y has the value 2. Now check this out. If I wanted to swap the values x and y, x comma y gets y comma x. Oops. Y comma x. All right? Because the values that these variables had before the assignment are the ones used in this tuple unpacking assignment. So after I do that, now x has the value 2 and y has the value 1. This is also very helpful when we get to functions later on. Whenever you want to return more than one value from a function, which is something that's very common to do, you can just return multiple values separated by commas, and it just returns a tuple. And many other programming languages, you would have to create some other kind of structure to do that, like a struct or a class or something like that. Okay? All right, so that's tuples. That's really about all there is to talk about with tuples. All right. When we talk about control structures, we'll see how useful tuples are in many contexts, such as enumerating the elements of a list, which is to pair the elements of a list with their indices and so on. And using that with tuple unpacking assignment makes for some very succinct and elegant code in Python. All right, the next thing to talk about is the dictionary. Dictionary is a really fundamental data structure in Python. It's used for many different things. Okay, so the way you create a dictionary, we'll do, how about caps for capitals, is we enclose a couple of ways we can do that. So one way to make a dictionary is to enclose a bunch of key value pairs between curly braces. So I could say capital of Georgia excuse me, is Atlanta, comma, and the capital of Florida, colon, is, what is the capital of Florida? Is it Tallahassee? Great, now I have to spell Tallahassee. Okay, so two elements in there. So now this is a mapping from the value Georgia to Atlanta and from the value Florida to Tallahassee. All right. And there's caps. Another way we can do this is we can say that caps is an empty dictionary, and now caps sub Atlanta gets, whoops, how about abbreviations? Gets ATL and caps Florida gets, oh, what's the airport code for Tallahassee? I'm just going to make something up. Okay. And now we've got these new values for caps. So let's talk about that conceptually for a minute. Okay, so now we've got caps. And it references a dictionary, and I'm going to draw these a little bit disconnected. So Georgia. And I'm going to disconnect these in Florida. And that's a kind of index that gets us the value, ATL. And this index gets us the value Tal for Tallahassee. If you're from Tallahassee, please don't be offended that I don't know your airport code. Okay. All right. Now, the reason I have disconnected these here and not drawn these connected as I did in the list is because even though indexing is very similar conceptually to the way that you would index with integers into a list, these index values, or we call them key values in a dictionary, don't have any particular order. So let's see what happens if I say caps.keys. Now this is going to do a weird thing, dict keys. So dict keys is a special kind of object, and at least it printed things out for us. You'll see other times where in Python you'll ask for something like, so if I wanted to enumerate the Starks, then I get an enumerate object. If I want to actually see what that looks like, I have to turn that into a list. Okay. Anyway, that's a little bit of a digression. We'll talk about enumerating over lists later. Okay. So caps.keys gives us the keys. Caps.values gives us the values. And caps.items gives us all the a list of tuples where each tuple is a mapping where the first element is the key and the second element is the value for that particular mapping. All right. Now, let's say that we let's say that we enter another capital for Georgia. We say caps GA gets Valdosta. What's the code for Valdosta? How about let's go Macon? I think that's right. It's been a long time since I've flown. Okay. So now what I've done here is I've actually reassigned the value that GA maps to. So if I look at my caps dictionary again, we see that the value that Georgia maps to has been replaced. It didn't add a second Georgia. The keys of a dictionary have to be unique, and that's one of the ways that that dictionaries enforces that. All right. Okay, so those are the basics of lists, tuples, and dictionaries. The next thing that we will discuss, will be functions, and then we'll get into control structures. And when we get into control structures, we'll see that there's a close relationship between many of the control structures in Python and the data structures in Python that make it very convenient to traverse the elements of a data structure in Python using for loops and so on. All right. So that is it for data structures.